All right, today we're going to dive into a fascinating and, frankly, a pretty counterintuitive story in the world of energy. We're going to explore what I call the shale paradox. It's all about how our relentless hunt for oil, crude oil, somehow ended up causing the single biggest drop in carbon emissions from the American electricity sector we've ever seen. It sounds completely backward, I know, so let's get into it.
So here's the central question, the big puzzle we're going to unpack. How on earth did a massive boom in drilling for oil lead to a huge drop in emissions from the power sector? I mean, on the surface, those two things seem like they should be moving in opposite directions, right? More oil drilling should mean more emissions, not less. But as we're about to see, there's a very direct, very powerful link between them.
To really understand this whole paradox, we have to start with a core scientific concept from petroleum engineering. It's something called the gas-to-oil ratio, or just GOR for short. Honestly, this one metric is the key to this entire story.
So what exactly is GOR? Well, the best way to think about it is like a can of soda. Deep underground, in a high-pressure reservoir, natural gas is actually dissolved inside the crude oil, just like carbon dioxide is dissolved in a soda. When you bring that oil up to the surface, the pressure drops and all that gas fizzes out. GOR is simply the measurement of how much gas fizzes out for a given amount of oil. It's how gassy the oil is.
And this is where it gets really interesting, because not all oil is created equal when it comes to GOR. Take a look at this data. You've got oil sands, which are not very gassy at all, very low GOR. Then you have conventional crude oil, which has a bit more. But then you have shale oil. The GOR for shale is on a completely different level. It's an order of magnitude higher. We're talking between 85 and 141 cubic meters of gas for every single barrel of oil. This incredibly high gas content is the defining feature of shale oil.
Okay, so we've established that shale oil is super gassy. Now let's look at what happened when the United States started producing this stuff on a massive, massive scale over the last decade or so.
Let's rewind the clock a little bit, back to 2014. At this point, the shale revolution was already well underway. You can see shale oil was accounting for about 4.1 million barrels a day. That's almost half of all U.S. production. So, a huge deal, but not quite the dominant force yet.
Now, fast forward a decade to today, and wow, look at that change. U.S. shale production has more than doubled. We're talking 9.5 million barrels a day, making up over 70% of the country's total oil output. And here's the kicker. Pretty much all of the net growth in American oil production has come from these super gassy shale fields.
And this, right here, is where the plot twist comes in. All of that new oil, coming from wells with those incredibly high GORs, had a massive, and I mean massive, unintended consequence. This is what we call the free gas phenomenon.
So all that gas that fizzes out of shale oil, it has a name, associated gas. And from an economic point of view, you have to remember why the drillers were there in the first place. They were chasing high-priced crude oil. That was the prize. The natural gas that came with it was just a byproduct. For them, it was a low-value commodity, and sometimes it was even a problem they had to get rid of. This basically meant a huge new supply of gas was hitting the market with a production cost of zero.
So how much of this byproduct gas are we talking about? The number is almost hard to comprehend. 43 billion. That's billion with a B. 43 billion cubic feet of natural gas every single day. That's the amount of gas being produced in the U.S. just as a side effect of drilling for oil.
Now, a number that huge can feel a bit abstract, so let's put it into perspective. Just look at this chart. That 43 billion cubic feet per day of byproduct gas from American oil wells is more than double the entire natural gas production of our neighbor to the north, Canada, and they're a major global energy producer. It's an absolutely colossal amount of energy hitting the market.
Look, you just can't inject that much of a commodity into a market without completely rewriting the rules of the game. This tidal wave of cheap associated gas created a tsunami that just shattered historical price relationships and completely reshaped the North American energy landscape.
And the proof is right here in the numbers. This chart tells the whole story. Before the shale boom, U.S. natural gas prices were regularly trading between $6 and $9. Then, the flood of associated gas hits, and the market just collapses. For the better part of the last decade, prices have been stuck between $2.50 and $4. The market was fundamentally broken and repriced at a much, much lower level.
It actually got so extreme that in places like the Permian Basin in Texas, where they didn't have enough pipelines to get all this gas out, the oversupply was just overwhelming. As this quote points out, the local price of gas actually went negative. Think about that. Producers were literally paying people to take their gas away just so they could keep their valuable oil wells pumping. It's incredible.
So let's connect all the dots and solve our paradox. We've got a historic boom in super gassy shale oil. That creates a structural, permanent oversupply of natural gas, which in turn makes that gas incredibly and reliably cheap. So where does it all go? Well, it goes to the single biggest fuel customer in the entire country, the power grid. And it is absolutely crucial to understand that this massive energy transition wasn't driven by some government mandate or climate policy. It was driven by pure, simple economics. The super low price of natural gas gave power companies a massive financial incentive to switch away from coal. So they started aggressively building new, hyper-efficient gas plants and even converting their old coal plants to run on gas instead.
And we're not just talking about a few plants here and there. The scale of this fuel switching, which the EIA tracked very closely, was immense. Just between 2011 and 2019, over 100 coal plants were either converted or totally replaced. 86 coal boilers were switched over to burn natural gas. This was a fundamental replumbing of the American electricity system, all driven by the economics of cheap, byproduct gas from oil wells.
And the end result of this decade-long shift? Today, natural gas is the undisputed king of the U.S. power grid. We now have over 500 gigawatts of natural gas power plants in operation, and it all happened because oil drillers were chasing crude in shale rock. That right there is the resolution to the shale paradox.
So the big takeaway here is that a huge chunk of America's power sector decarbonization wasn't really the result of deliberate climate policy. It was an unintended consequence, a side effect of geology and oil market economics. And it's just this powerful reminder of the law of unintended consequences. It really makes you wonder, doesn't it, as we push forward with electrification and new energy sources, what other surprising side effects, both good and bad, are waiting for us just around the corner?